We are still talking about moments of inertia of areas. In the last couple of sections and examples, we were looking at the integration method. Now what we're going to do is we're going to go back to composite bodies. I'm going to call it composite areas here because we're just dealing with areas. Now what we're going to do here is just like when we did composite bodies with centroids, we're going to use this method whenever we have areas that can be easily split into geometric shapes. So we're looking for the circles, the triangles, the rectangles, those types of things. And the reason why we want to do this is because in our tables that we use for centroids, we go back here, like I showed you all before, we've got these equations for moments of inertia about the axes shown. All right, so that'll save us some work there. Now, once we break it into the geometric shapes, we can find the moments of inertia for those individual shapes, and then we're going to put it all together using summations. We're going to construct a table. It's going to be similar to what we did for the centroids. We're going to have the columns that are shown. We'll have our region. We'll find the area. We'll have our dx, our dy, then multiply the area times dx squared. You'll have area times dy squared. And then we're going to have the ix bar and iy bar. And I'll tell you what all these are when we get to the examples. So you'll fill those in, and then you will sum up the areas. You're going to sum up the a dx squared. Column, same thing with a dy squared. And these last two. All right. So that's what we'll be doing. And then once we have this, we go back to those parallel axis theorem equations. So remember, that's Ix equals the summation of the I bar x prime. Remember, x prime was that centroidal axis. Then we have plus the summation of a dy squared. Then for Iy, you have a similar one, except for now you'll have the summation of Iy prime bar plus the sum of the areas times dx squared. And then Iz is going to be Ix plus Iy. So these will be the equations we're going to use. Just the parallel axis theorem, but now we have it in terms of summations. And before we go forward, let's redraw our diagram so you know what these distances are. So here's x, here's y. We had an area, and then we had a dA. Now let's say the centroid of this big area was right here. Remember, we put axes through that centroid. We had x prime, y prime. And then we measured from this centroid here to the dA. So this distance here was y prime. This one was x prime. And we were looking for the moment of inertia about this x-axis and then this y-axis. So we needed to measure up here to the centroid. So this distance was the dy, and then this one was the dx. Okay? So just keep that in mind when we're going through the table. So we got centroidal axes. Remember, those are indicated with these bars. The bars here indicate centroid. All right, so let's stop the notes here, or the video here. We'll pick it up next time with an example.